Okay, now we are going to start a new chemical properties, that is oxidation. That is oxidation of this aldehyde and ketones. So this oxidation you can see basically this aldehyde is oxidized directly into carboxylic acid, and if you are going to oxidize this ketone, there will be cleavage of bond, and each uh, or whatever we have divided into two parts, that will be converted into carboxylic acid in the way as you can see. Can you see the screen?
Yes, sir, can see the screen.
Wait a minute, please. Okay, am I audible clearly?
Yes, sir.
So this aldehyde can be directly converted into carboxylic acid having 3 carbon. That means this propanol will be directly converted into propanoic acid. Propanoic acid. So it's very simple to oxidize an aldehyde than a ketone, because if you are going to oxidize a ketone, there will be cleavage of bond. So first of all, are you done with this? Let me know when you are done with this.
Yes, sir, finish.
Okay, when we are going to talk about this ketone, so as you can see, I'm going to take a general formula of ketone, RCH2, C double bond O, and this is your CH2, hard S. And if you are going to oxidize this, I'm going to number it from where we are going to break it. So I'm going to take this 1, 2, 3, and you can take it from right to left or left to right. First, you are going to break this 1 and 2 bond. This. If you are going to break the bond between C1 and C2, then you are going to make a carboxylic acid or prepare a carboxylic acid having carbon this much. So this will be basically RCOOH, and the next product will be basically this much carbon of carboxylic acid. So this will be R-CH2, and this carbon will be converted into carboxylic acid, the last carbon. So this product is this product we got from the cleavage of by cleavage of C1C2 bond, C1C2 bond. And if you are going to break between this 2 and 3, you can see this is the first product, second product, and third product you are going to get it from here, that is R dash, and this carbon will be directly converted into COOH, so it will be COOH. And then again you can see from here you are going to make it RCH2 COOH, and this we get from C2C3. So we will get basically four products here. You can see. If you still have any problem in this or doubt, you can ask me.
Yes, sir. Finish.
Very good. Now we are going to see there are some oxidation method that will be used to distinguish between aldehyde and ketones. Not all reagents can directly convert this ketone into carboxylic acid, but they can convert aldehyde into carboxylic acid. That means that reagent we are going to use which cannot convert ketone to carboxylic acid, that will be used to distinguish between carboxylic acid and ketone. So they are basically known as mild oxidizing agent. Basically, a strong oxidizing agent, weak oxidizing agent, and then in between these strong and weak, there are mild oxidizing agent. So we call it basically there are right with me there the mild oxidizing agent. We can write. I just write milding. The mild OA stand for oxidizing agent given below, used to distinguish between or distinguish aldehyde and ketones. Aldehyde and ketones. Is that clear? So the first we are going to use is tolerance test and tolerance reagent. We can say tolerance test. Basically, we use a tolerance reagent, and that is your ammonical silver nitrate, which is a mild oxidizing agent. That means it will oxidize aldehyde into carboxylate anion or carboxylic acid. Basically, it will oxidize aldehyde into carboxylate anion, and it will reduce itself, but it cannot oxidize this ketone. So this test is used to distinguish between aldehyde and ketones. Now see what we do here. On warming an aldehyde with ammonical silver nitrate, ammonical silver nitrate, which is also known as nitrate, it is ammonical silver nitrate, which is also known as tolerance reagent. Tolerance reagent. A bright silver mirror is formed. A bright silver mirror is produced or formed due to formation of silver metal. Due to formation of silver metal. And this aldehyde is oxidized into carboxylate anion. So we can write aldehydes are oxidized to carboxylate, or we can use corresponding carboxylate anion. And also it is very important to note reaction occurs in acidic medium, basic medium. Reaction occurs in basic medium. Please do write it and let me know.
Yes, sir. Done.
Very good. Now I'm going to show you the reaction. So basically, this is your aldehyde, and you are going to warm this aldehyde with ammoniacal silver nitrate solution, which is known as Tollens reagent. Basically, this is your Tollens reagent, and it occurs in basic medium. So this aldehyde will be directly converted or oxidized into carboxylate anion, and this Ag, which has a +1 oxidation state, will be reduced, and then there are other products which is basically byproducts. This reaction will not occur for ketone, so that will distinguish between ketone and aldehyde. Please do write. Do let me know when you are done with this.
Yes, sir. Done.
Very good. So there is another test that is known as Felix test, and it is almost same as this. There will be also formation of carboxylate anion, and it's very easy. So this is also a test which is very important. So as you can see, this is your Phalanx test. So this is your Phalanx test, and in this we have two containers, Phalanx A and Phalanx B. So basically, I'm gonna write this is your Phalanx A, and this is your Phalanx B. And in Phalanx A, we can see that Phalanx A is aqueous copper sulfate solution. Aqueous copper sulfate solution. Whenever copper sulfate in aqueous solution, that will make basically CuSO4.5H2O, which is also known as blue vitriol. This is also called blue vitriol. Water of crystallization is there. And in Phalanx 2, basically this is Phalanx B, what I call just Phalanx 2. This is the second container in which sodium potassium tartrate is present. Sodium potassium tartrate, which has a common name and known as Rossel salt. So these two are mixed in equal amount before test. So I'm gonna write these two are mixed in equal amounts before test, just before test. Now I want you to I want you to answer me. Can you tell me what is the oxidation state of copper here? Can you tell me the oxidation state of copper in CuSO4? Yes or no, Nafisa?
No, sir.
Okay. Can you tell me what is the charge on sulfate? What is the charge? -2, yes or no? Do you know about this
Yes, sir.
sulfate ion? Sulfate is SO4 -2. And if there is copper and they form a compound and there is no charge,
Cu2
that
plus.
means copper must have +2. Cu +2 or +2, 2 plus. Are you getting my point? That means this is +2.
Yes, sir. Yes, sir.
Now see, if they are going to mix in equal amounts just before test, what will happen? Now we are going to heat on heating an aldehyde with Falling's reagent. These both are known as Falling's reagent. On heating an aldehyde with Falling's reagent, a reddish brown precipitate is obtained. A reddish brown precipitate is obtained, and aldehyde is oxidized to again. Aldehyde is this aldehyde oxidizes to corresponding carboxylate anion. So we can write aldehyde. This is your aldehyde. Aldehyde oxidizes to corresponding carboxylate anion. Please do write it, and then I will show you the reaction.
Yes, sir. Done.
Very good. Now see what happens. As you know, this copper sulfate, in this copper sulfate, Cu will have +2 oxidation state, and this is RrCHO, which is an aldehyde, and you are going to again carry this reaction in alkaline medium. Then again, this aldehyde will be converted into carboxylate anion, and since this is your oxidizing agent, that means it will reduce itself. So it will be reducing itself and it will have oxidation state +1 now. And this is your red brown PPT. Red brown PPT. And along with this, we get 3H2. So basically, this is the reaction for Falling's reagent. And also, it's very important to note that this reaction is not for aromatic aldehydes. So I'm going to write aromatic aldehydes do not respond to this test. Why it is so? Because aromatic aldehydes are very, very stable. That's please do write it and let me know when you are done with this. Do let me know when you are done with this.
Yes, sir, done.
Very good. Now see, another chemical reaction, that is the last chemical reaction of this oxidation reaction. The last oxidation chemical reaction of aldehyde and ketones is this oxidation of methyl ketones of methyl ketones by haloform reaction by haloform reaction. And it is very important and very easy. If you have any ketone which have methyl group, so how we are going to recognize? So if you have CH3 nearby or alongside C double O, that is known as methyl ketone. So this is your methyl Nafisa, and you can, sorry, this is your ketone and this is your methyl. So it is basically what? It is your methyl ketone. And if you are going to react this with NaOX, you will get RC double bond O, ONA. You are going to replace this whole with NaOA, and we will get as a byproduct this haloform CH3X. And here X is only for chlorine, bromine, iodine, not for fluorine. Fluorine is a small and highly electronegative. So we can write a point. Aldehydes and ketones. Wait a minute. Can you see the screen?
Yes, sir, can.
Okay. Aldehyde and ketones having at least one methyl group, having at least one methyl group linked to carbonyl carbon atom. That means really we can say methyl ketones are oxidizes are oxidized by sodium. We say it is hypohalite. Sodium hypohalite to sodium salts of corresponding carboxylic acid. This is your, if you are going to replace this Na and replace this Na with H, it will be carboxylic acid. And if you are going to use metal, that is basically sodium salt of carboxylic acid. So we can write hypohalite to sodium salts of sodium salts of corresponding carboxylic acids. And you can see there are you can see two carbon with one alkyl group, but in the product you will get only two carbon. That means basically whatever is the number of carbon in reactant, the number of carbon in product will be lesser, one lesser than the previous one, reactant one. Are you getting my point?
Yes, sir.
Very good. Having one carbon atom less than that of carbonyl compound. Please do write. So this methyl group is directly converted into halo. I'll show you a reaction. It's very easy. How was your mock test?
Um, it was fine, I guess. I don't know.
Only fine. Okay. So there were MCQs, assertion and reason, and then there are subjective questions also. Mhm. There were again MCQs, and then again define the following terms. I think the paper was quite easy. Should I score them? It is only for 50 minutes
Yes, sir.
and of 27 marks. Okay. Now to let me know when you're done with this.
Yes, sir. Finish.
Very good. I'm going to give you a reaction from the NCRT, which is very easy, and I think you can do this. Let's see. And so, what is the timing of your board exams? Do you know? In March, have you got the notice?
No, sir. Not yet.
Okay. Please do this reaction. Do let me know when you're done with this.
Yes, sir. Finish.
So what you need to do here, it's very simple. You are going to replace this. You can see this is your functional group and this is your methyl. So we can say this is your methyl ketone. So the rest part will be as it is. The rest part will be as it is. And you can see this is your C double bond O, and this will be oxidized.
Yes,
This
ONA.
will be oxidized into what? ONA, ONA, ONA. Yes, this will be oxidized into 1A, and this CH3 will be converted into halofoundation.
CH3 Cl.
Cl. Very good.
Yes, sir.
So, are you done with this? Very good. So I'm going to change the slide and I'll show you another reaction which is very important, which is known as aldol. So see, the next chemical reaction, that is reaction due to alpha hydrogen. Reaction due to alpha hydrogen. Can you calculate alpha hydrogen in a compound which has aldehyde or ketone or any functional group? Can you calculate it? Yes or no? Okay, let's see. Nafisa, it's very easy, and there is another topic of this for this, that is acidity of alpha hydrogen. Acidity of alpha hydrogen of aldehydes and ketones. Do you know if any compound which has alpha hydrogen, it will be this alpha hydrogen is very, very acidic in nature, because this alpha hydrogen will be released in the form of H plus. That will show it is acidic, and if there is any alpha hydrogen, it will release itself very faster. That means it is very, very acidic in nature. Are you getting my point?
Yes, sir.
Nafisa. Now see how you are going to recognize whether the alpha hydrogen is present or not. So as you can see, this is your functional group C double O, aldehyde, and this is your functional group ketone. So the carbon which is directly connected to the functional group is known as alpha carbon. As you can see there in ketone, there will be two alpha carbon. Alpha carbon, this one is alpha carbon, and also this one is also alpha carbon. So the carbon which is directly attached to the functional group are known as alpha carbon. And if you're going to see about this, this will be your beta carbon, because this carbon is attached to the alpha carbon. Are you getting my point? But now, right now, you are going to focus on alpha carbon. So I was talking about alpha hydrogen. So the hydrogen which is attached to alpha carbon is known as alpha hydrogen. So there is two alpha hydrogen here, and here you can see six alpha hydrogen. So I'm going to repeat what is alpha carbon. So the carbon which is directly attached to the functional group is alpha carbon. And what is alpha hydrogen? So the hydrogen which is attached to alpha carbon is known as alpha hydrogen. Is that clear?
Yes, sir.
Very good. And also this is very important to note, this alpha hydrogen is acidic in nature. As you can see, if I'm going to show you, this is your it can be carbonyl. Basically this is your carbonyl, and this is like this. And there is a base, that means, or you can say nucleophile. So as you can see, this is your functional group. If you are going to consider it, this is your alpha hydrogen. So what is alpha hydrogen? Alpha hydrogen is very acidic in nature. So what it will do, it will give electron to carbon, and it will release itself in the form of H plus. And H plus has deficiency of electrons, so this base or nucleophile will attack on H. So now what we will get, it's very easy to understand. This will be as it is, but now as you can see, this will have negative charge. Now I'm going to change the arrow. So as you can see, this will give electron to carbon, so it will have negative charge, and there was bond. Now there will be resonance. As you can see, this will take electron from here, and it will be like this. So in this way, and there was bond, so it will be like this. Are you getting my point?
Yes, sir.
So please do write.
Yes, sir. Finish.
Very good. Now see, write a topic, aldol condensation. First, we are going to talk about aldol condensation. Then we will also talk about cross aldol condensation. So see, what is this aldol condensation? First of all, I'm going to write a point about and then explain with the help of an example. So write with me, please. Aldehydes and ketones having at least one alpha hydrogen, undergo a reaction in presence of dilute alkali as catalyst to form beta hydroxy aldehydes. You will see it's all very easy. Just write with me, which is known as aldol. Ald means aldehyde and all means alcohol, or also known as beta hydroxy. That means basically the alcohol's position is at beta carbon ketones. If there is ketone, if you are going to do this condensation of ketone, that will be known as ketone, respective. This is known as this is known as aldol reaction. So first of all, you are going to write it, and then I'm going to explain it with an example.
Yes, you can.
Very good. So I'm going to explain it. First of all, Nafisa, it's very important to note that if there is any aldehyde and ketones, that ketone or aldehyde must have at least one alpha hydrogen, at least one alpha hydrogen. If there is more than one alpha hydrogen, that is okay, but at least there must be an alpha hydrogen. And this reaction we do in the presence of dilute alkali as catalyst to form beta hydroxy aldehyde. What is this beta hydroxy? As you know that hydroxy we use for alcohol, and aldehyde is senior functional group than alcohol. So with respect to this aldehyde, the position of alcohol will be beta, which is also known as aldol. Ald for aldehyde, ol for alcohol. Or we can say beta hydroxy ketone if the main functional group that we have taken initially, if that is ketone, that will be basically then ketone. Ket for ketone, all for alcohol respectively, and this is known as aldol reaction. Now this is known as aldol reaction. I didn't tell you what is aldol condensation reaction. I just explained the aldol reaction. Is that clear?
Yes,
Nafisa?
sir.
Okay. Now let's see what we have. Let's take an example of this ethanol. So can I write this ethanol as this? So as you know, this is your main functional group. So this will be your alpha carbon, right? This will be your alpha carbon. So if alpha carbon is this, that means this is your alpha hydrogen. So can I write this CH3CHO as this? Yes or no? Can I write this?
Yes, sir.
Wait a minute. minute, let me. Okay. Nafisa, so this is our alpha hydrogen. This is our alpha hydrogen. Now, what you need to do, this reaction is taking place in the presence of dilute alkali. So I'm going to make it dilute NaOH. See, understand the step. It's very easy. So what you need to do, since it is alpha hydrogen, what I told you, it will be very, very acidic in nature. That means it will eliminate in the form of H plus. Eliminate in the form of H plus. That means carbon took the electron from hydrogen, and now this carbon will be CH2 minus, and this will be CHO. Yes or no? Yes or no?
Yes, sir.
Please do let me know. Now, or I can write this, or I can write this CH. Now see, again you are going to take, we basically in this aldol reaction, we require, or we will in need of 2 mole of this. So I just used 1 mole of ethanol. Now I'm going to use another mole of ethanol in this form. Can I write this? We use generally 2 mole of ethanol and 2 mole
Yes,
of
sir.
aldehyde or ketone. What I want to say is that, is this nucleophile or electrophile? Can you tell me what is this? Nucleophile or electrophile? Do you know what is
Electrophile.
nucleophile and electrophile? Electrophile is the one which is electron lover. That means the one which has deficiency of electron. And as you can see, this has a negative charge that represents 2 more electron and which is rich in electron. That means it is nucleophile. Any compound which has negative charge or the lone pair present on that is a nucleophile,
All right.
which means
Yes, sir.
nucleus
Yes.
lover. So this is nucleophile. So always remember, if you are going to take H plus from here, it will form, what it will form? It will form nucleophile. And when you are going to take another mole of this ethanol, what you need to do is make this electrophile. How you are going to make an electrophile? Electrophile is the one which is deficiency, which has deficiency of electron. So as you know, this electron is more electronegative, so it will take electron from carbon. Are you getting my point?
Yes, sir.
Nafisa? So there will be deficiency of carbon, sorry, electron on this carbon. So this will attack on this carbon. Now see, this is your CH3, I'm going to write. Now this is your CH, I'm going to write. And there is O, and which has negative charge. Now since this CH2 attacked on this, so it will be forming a bond with this, and then there was CHO with this. So can I write this? Nafisa, please do let me know if you need another explanation of this.
No, sir.
Okay. Now you are going to do hydrolysis. That means hydrogen or water has 2 parts, H plus and OH minus. And this H plus will be going with this. So what we got is CH3, CH, CH2, and CHO, and this is your OH. Yes or no? So this reaction is known as basically aldol. I'm going to explain it. Aldol reaction, or we can say beta hydroxy aldehyde. Beta hydroxy aldehyde. Now alpha beta, I'm going to explain this. Wait a minute. Oh, wait a minute. Okay, see, this is your main functional group. So basically this will be alpha and this will be your beta. Yes or no? Nafisa?
Yes, sir. Yes, sir.
So on the beta, it is hydroxy. So I just wrote beta hydroxy aldehyde. Please do write it because it's not erasing. I'm using eraser, but it's not. Please do write it.
Yes, sir. Finish.
Very good. The reaction did not complete here. I'm going to explain. Basically, this is only aldol reaction. What is aldol condensation? So I'm going to write this again with this CH3, and this is your CH, and this is your OH, and this is CH. I'm going to write it as H, and this is CH. So if you are going to again repeat this, if there is a question, write the product for aldol condensation. What is aldol condensation? Removal of water, condensation. So what you need to do, take out hydroxide from beta, and always take out hydrogen from alpha. Hydrogen from alpha. If you are going to make basically this, what you need, this is your alpha, this is your beta. So basically this is the product you will get, and the product you will get at the end is known as you can see, this is ene, that is basically double bond, and this is aldehyde, that is known as enol. Also, if you are going to remove OH from here and hydrogen from here, you will get a product CH2 double bond CH, and then CH2, and then CHO. It will be minor product as compared to this, because alongside this, this double bond is in symmetry, or you can call it in Sadjeff rule that we have studied it in haloalkanes and haloarenes, I think there. So what we get there in elimination reaction, alongside double bond or alkene, if we have more alkylated part, so that will be the more stable. So there are more reasons that this is stable, that means it is major. So always remove hydrogen from alpha, and we get OH on beta. So you will get removing of water, removal of water, elimination of water, you will get this. Is that clear?
Yes, sir.
Please do write it. And let me know when you are done.
Yes, sir. Done.
Very good. So I'm going to again explain this so that it will be very easy. So if I'm going to give you ethanol, at the place of ethanol, I am going to give you propanol. So what you need to do, just make a nucleophile. How you are going to do it? Just remove hydrogen, alpha hydrogen, one of the alpha hydrogen in the form of H plus. So this carbon, whatever is the carbon connected to that alpha hydrogen, will have negative charge. Now it will act as nucleophile. Now take another mole of this and then make it electrophile. How it is possible? C double bond O, carbonyl group. Oxygen will take electron from carbon. Carbon will have deficiency of electron. That means it will be acting as electrophile. So this negative will attack on that, and in this way you will get this, and then again react with this H2O. That means H plus will attack this, and you will get our reaction that is known as aldol reaction and also known as beta hydroxyaldehyde. And if you want to write the aldol condensation after forming this beta hydroxyaldehyde or aldol, you are going to remove water. And how you are going to remove water? OH will be on beta, and from where the next hydrogen you are going to remove is from alpha. Always do this, you will get the major product directly. Are you getting my point?
Yes, sir.
Very good. So I'm going to give you a question. It's very easy. So see, I'm going to give you, this is CH3, CH2, CHO. First, you are going to do this reaction in the presence of dilute alkali. Please.
Yes, sir. Done.
Are you done with the product? Have you got this? Oh, it will be CH3. Oh, what you have got? Can you tell me?
CH2 CH. No, CH2 double one. CH2
Wait a
double
minute.
one CH.
Did you solve it stepwise that the way in the way I explained, or you just directly wrote the answer?
I directly wrote the answer.
No, don't do it. Just do follow the steps also.
Okay,
Okay.
okay.
Okay. I'm waiting. Are you done with this?
Yes, I guess.
You guess. Very good. Now see. Can you tell me this carbon 1, 2, 3? Which one is alpha carbon?
Alpha
One,
is
two, or
the
three?
second one.
Second one, second carbon. So, so I'm going to write this, and this will be like this, and it will give electron to its carbon, and you will get this CH negative and then
CH3C
CH2,
negative.
then
Yes, sir.
CH, yeah, and then again you are going to take this, and you need to make a new electrophile now. And how you are going to do it? It's very easy, and this will take electron from here, and it will attack here, right? So I'm going to write
Yeah.
this part first. So as you can see, this will be CH3, this will be CH2, and this will be CO negative, and this is H. Now, since this carbon is attacking on this carbon, so it will be CH. And after this CH, there is CHO. And you can also see this is CH3, which is attaching with this CH minus, so it will be CH3 like this. And you are going to do this H2O, that means H plus or OH minus. So this H plus is going to attack on this, and in this way you will get a beta hydroxy aldehyde CH3 CH2, and this is CH, and then again OH, and then again CH, and then there is CH3, and then there is CH. So as you can see, this is your main functional group. So this is alpha and this is beta. So this is beta hydroxy aldehyde. Now you are going to uh, do the aldol condensation, that means H2O, removal of H2O. So what I told you to do, remove OH from beta and remove hydrogen from alpha. So you will get CH3, CH2 as it is, and then now it will be CH, and now there will be double bond, and this CH is already gone with this OH. So you will have left C, and this CH3 is connected with this C. So in this way, you will get a product. This is the main product after
Sir, how did you
this.
do the second step?
This minus H2, are you talking
No,
about this,
no, the
or
green
are you
one.
talking about this one?
Yeah, that one. Yeah. Yes, sir.
See, are you comfortable up to this part?
Yes, yes,
Yes
yes,
or
sir.
no? Okay. Now see what happens. Since we are going to make a nucleophile, so this O will take electron from carbon, yes or no?
Yes, sir.
So there will be deficiency of carbon, sorry, electron on this
Yes.
carbon. So this negative is going to attack on this. So I'm going to write this part first. So you can see this is CH3, this is CH2, and this is C and O, H, CH and O
Yes.
negative. Are you getting my point? Now, after this, you are going to attack this with CH directly. That means this negative is going to make bond with this carbon. So this CH will be directly attached with CH, and this CH is with two group, that is CHO and CH3. So I have written CHO here and
Okay.
CH3 here.
Yes, sir.
Okay. So please do write it. Are you all? Is it correct, or you have done some
No.
mistakes?
Yes,
No.
obviously.
Okay, okay. Do practice, do revise. It's all very important. And your nomenclature that you have sent me is very, I think it's almost wrong. All of it. Not
Yeah,
all of
all of
it, but
that is wrong.
yeah, you should take care of it because exams is nearby. Please, if you are writing, please do write it.
Yes, sir. Finish.
Very good. So I'm going to give you some question again. Hmm. Have you written it?
Yes, sir.
Okay. So please do send me today also. Okay.
Yes, sir. Okay.
After completing it, you may leave. Nafisa,
Yes, sir.
and
I'll
an
send
extra
it to
class
you
on
now.
Friday.
Oh, okay.
Yes,
Um,
yes. Okay.
Friday.
Thank you.
Sir, I can't take extra class on Friday. Friday, I think I'm going out
Yes.
somewhere.
What is it?
Friday, I'm going out
Okay, no
somewhere.
problem.
Yeah,
Okay, no
okay.
problem.
Okay, sir. Bye. Thank you, sir.
Davis, wait for few minutes. I'll be back. I just overed my class.
Yeah, good evening, sir.
Good evening. Just wait for few minutes. I just overed my class. I think.
Okay, okay, okay.